Okay, we're looking at a question involving proportional reasoning, and we're going to use the method of algebraic reasoning to solve this. The overall expectation is to solve problems involving proportional reasoning, and the specific expectation solve problems involving ratio rates and directly proportional relationships in various methods or contexts, as our case algebraic reasoning. So let's take a look at this question. We're going to read through it once, then we're going to look what's important, and the second time through we'll highlight. So the table below shows the cost of water for 3 different customers. They each pay the same cost per liter. So here's our table. Gabriel pays $46 for water at the same rate. Determine the number of liters of water that he purchased. So let's highlight what's important here. We have 3 different customers in our table below, and they pay the same cost per liter. Okay, so here's our table below. Let's call this customer 1, customer 2, customer 3. Gabriel pays $46 for water at the same rate. Determine the number of liters. So, number of liters of water that he purchases. What we're going to be doing here is we're going to first classify everything we have here. We have a liter amount, okay, and we have a dollar amount. Okay. We want to be able to build an algebraic equation representing this relationship. So, what we're going to do is we're going to set up our liters as one category and our dollars as another. Okay. And we're going to use one of the customers because all of the customers are technically paying the same rate. Let's try customer 3 for this one. Okay, so let's take their information. They actually purchased 30,000 liters of water and they paid $27.60 for it. Okay. What we want to do, because Gabriel's amount is in dollars, okay, and because this relationship depends on the amount of liters purchased, will determine how much money you've spent. We're going to try to build an equation. So we're going to call our liters our y variable and our dollars our x variable. From here, what we're going to do is we're going to figure out how much $1 gets us in terms of liters. So in order to do that, the idea is we need to bring this down to $1. So what relationship, decreasing relationship, would take 27.6 to $1? Well, we can divide. We can divide by 27.60, and that'll take us to $1. In that same idea, okay, we will be dividing our liters, okay? And this will end up being our rate here. So we're going to divide our 30,000 liters by 27.6. So let's take our calculator out. We get our 30,000 liters, and we're going to divide them by 27.6. And we get 1,086.956. Let's round it to 0.96. So 1,086.96. 1,086 point, I think it said 96. I'm just make sure. Yeah, 96. Okay. So for every dollar we spent, we get 86.96 liters. So let's build a relationship here. Because this is going to be a direct relationship, okay, our amount of liters is our unknown. Okay, so we have y being our unknown in liters is equal to x is representing our dollar amount, and we have some rate. Okay, our rate, we'll call this an m in this case. Okay, that's what this number is here. We figured out the rate when we divided this and brought our dollar amount down to 1. Okay, here was our rate. It's a 1,086.96. So here's our little algebraic equation. Y is equal to 1,086.96 times our x, which is the amount that Gabriel spent. We know that Gabriel spent $46, so we're going to replace x with that amount to figure out how many liters we get. So I'll write the rest in black here. Y is equal to 1,086.96 times the $46 that Gabriel spent, okay? And what that'll give is the amount of liters he purchased. Now we did a little rounding with this rate number, so we're going to see what value we get. 1,086.96 times 46. And we get 50,000.61. If we were round to the nearest whole number, it would be 50,000. 50,000. And you notice that 0.16, or I think I said 6.1. That 0.16 is due to our rounding. The true number is 50,000 in this case. Now, we could have done this another way. You see how we reduced our dollar amount to $1? We could have reduced our liter amount to 1 liter. Okay, so let's go through that same process and see how we kind of build the equation algebraically and how this works. So we'll take the exact same customer, and remember they had 30,000 liters. Well, we want to reduce this to 1 liter. The amount they paid was $27.60. Okay, so in order to reduce 30,000 to 1, we know we have to divide by that number, just like we did with 27.6. So we're going to divide by 30,000. 30,000 by 30,000 is 1. We also need to divide 27.60 by 30,000. So we're going to divide by 30,000. Now this is going to give us a pretty small decimal value. Let's see what we get. 27.6 divided by 30,000. Okay. 3 zeros, so decimal place 3 zeros, 92. Okay, so 0.00092. This is our new rate. Okay, well, and how do we build our algebraic equation? Remember we used x and y before, so let's move this over. Let's put some statements on what x and y were. Remember, y was liters, and in this case, it was our total liters, the total number of liters that we purchased. And x was the amount of money, so this is our dollar value, was our x. And our rate, this m value, in the other question, okay, in the other question we did, it was liters, okay, per dollar, okay. And that's why we multiplied it by dollars, okay. Whatever our per is the unit that we'll be multiplying by. So in this case, let's set this question up a little differently. We're going to have x, remember that represented our money value, so we're going to have our total money, our rate, which is our m. Our rate is dollars per liter now, and that's what this rate is that we just found. And because it's per liter, we're going to be multiplying by liters, so we're going to multiply by y. This may look a little different, but it's essentially the same idea. We just have a very different rate. So we plug in our new rate, okay? So x is equal to, remember our rate being 0.123092 times our y, which is our liters, okay? Well, remember y is our unknown. We don't actually know it, but we do know our total money. Gabriel spent $46, so we're going to replace this x with 46. So 46 is equal to 0.00092y. The goal is to isolate for y right now. Y is our total liters, that's what we're trying to figure out. And because it's this rate times y, in order to reduce it to 1, we need to divide by this. So we'll divide both sides by that. A lot of times they call this canceling out, but really what we're doing is reducing that value to 1. Okay, so these become a 1 value, so we have 1y is equal to 46 divided by this really small decimal. 46 divided by this small decimal here gives us 50,000. So we came at this 2 different ways, and both of them we got 50,000 liters for the amount of water Gabriel purchased. If you'd like to see other ways of how to solve this question, look at our other playlist on proportional reasoning.